All right. Hi, how you doing? My name is Rob Froman, and I'm here to talk to you today about how we might aggregate velocities across engineering teams. This goes right to the heart of the measurement and transparency aspects of Scrum and Scale. I had an opportunity to work in a lean startup inside of a large technology company, and we had to grow a team. We started off with about 10 people and grew it to about 25, and we started co-located and ended up with 25 people across 3 geos. So it was an interesting opportunity for us to look at how does the team scale over time. Now, of course, as you can imagine, tight engineering teams like that might not like to be measured. They didn't actually see the whole lot of value in it, but we persisted, and it's about 2.5 years worth of data that is going to reflect some of the outcomes we came up with. Some of the decisions we made were secondary, and I hope if I have some time, I'll get to them at the end. But I want to focus on four measures here: linearity, stability, focus factor, and the impact of deadlines. So we'll step through some of these here. All right. So linearity, the idea of linearity is as a team grows, you would kind of hope that if you double the staff, you at least double what you're actually producing. And very often, anecdotally, we know that doesn't really happen. So this is the idea of it. We actually had an opportunity to measure it. So the largest amount of the team growth, which you'll see here in a second, happened at the very early in the company, and then the team stabilized. And it's interesting to see what happens with the velocity. These teams, just for the record, the velocities were aggregated across all 5 of these teams. We didn't worry about normalization because really we're looking at percent complete per iteration as opposed to total points, but the teams were pretty even in their velocities anyway. All right, so what we see here, the green line there demonstrates the team growth over time over about 2.5 years. The blue one is a second order. It did as best as I could for the regression here. And it's for human behavior type measurements. This actually worked out pretty good to the data. And as you can see, we beat linearity fairly early on. And then as time went on, we started to fall away. And when you talk to the teams and find out what's actually happening within them, it's interesting to see. We had a number of deadlines come up. There were greater dependencies between the teams, and practice eroded. Simply, we just weren't as rigorous and disciplined about how we did our practice, which was an interesting outcome. I didn't think it was going to be this dramatic, but there it was. The second one is stability. This was actually kind of a surprise to me. I did this almost on a dare. I aggregated why not, right? I aggregated the velocities across the 5 teams for a quarter. And because I wanted to see how stable are these teams in aggregate, right? An engineering team, these engineering teams individually might have their velocities change by upwards of 50% sprint to sprint. But how did this happen when you aggregated it? And hopefully we don't have a situation where the normalization washed out the data, but what it came up to was the teams hit about 1,250 story points per quarter, plus or minus about 10%. It was shocking, actually. And this is over the course of 6 or 7 quarters here. So what this helped us understand very clearly was we could work with the product organization, and if the product backlog had 1,800 story points in it for the next quarter, there was no way it was going to happen, right? And if the data helped us make that case, how do you want to prioritize your backlog? And it became a very powerful tool for helping us understand how to prioritize. The third one is focus factor. This one we measured primarily because this was a very high-power team. However, they fell prey to the age-old concern that I look at the team velocity and that's what I get out of my product velocity. So we made it very visible in the organization. And as you can expect, roughly 50% of the capacity went to the product backlog. The other 50% went to 2 primary areas: infrastructure and defect work. So that might be technical debt, bugs, and so forth. So this is the velocity over time. You can see it varies very much across the period of time here, with the average being about 50%. You can probably figure out what the releases are just by looking at this data. And what's interesting here too is that you need to look at this as a dial, not a budget. This is a lagging indicator. So I think one of the dangerous patterns here is that you turn it into a leading indicator and you try to fix it and say, well, we're going to do 40% feature development for the next 6 months. It doesn't work that way. You have to look at it and maybe set your targets, look at it in retrospect, and see if you're actually hitting what you're trying to achieve. And this does reflect some of the decisions, the business decisions we made as we came closer to a release. We'd actually reduce the amount of infrastructure work we might do, which is why you probably see the product velocities coming up. All right. And the impact of deadlines, the data is not great here, but I want to show the data anyway. But the red lines indicate the releases. What we found was a pretty interesting pattern. As you can imagine, the teams would start to, we'd have a release come up and the teams would start cranking, right? They'd be up all night and their velocity would increase by upwards of 50%. And we get to the sprint demo and everybody, the aggregate, the group sprint demo, and everybody would jump up and down, look how awesome we are, right? I knew what was going to happen, right? After the release, it took on average, about 6 sprints. We were doing 1-week sprints, about 6 sprints for the velocity to come back up to normal again. So it was a big peak and then a big drop off. And that lack of evenness affects your predictability. It contributes to the teams getting burned out. And it was a very interesting pattern to actually see it show up in the data a little bit. This could use a little bit more analysis, but anecdotally, it was there. What I was doing here was to see if the data actually matched the stories that were being told. So the takeaway on this is you can measure in aggregate. Okay, you can look at large organizations. This was, again, 5 engineering teams. I would recommend that maybe upwards to 7 teams, maybe less than 100 people. You're not going to do this for 60 teams. I would suggest that that's probably not going to help very much. But in a program or portfolio level item like that, it can be very insightful it can provide some real deep insights into what the behaviors of your teams are. With that, I'll close. Thanks.
Rob, I'm assuming that I'm assuming that the velocity chart that you showed, that the dips were maybe 4th of July, Christmas, Thanksgiving. Did you have the opportunity, or do you have the data available to show velocity over capacity, i.e. number of man days or something, where you could actually see how that is impacting?
We could. There wasn't a whole lot of impact on the vacations. As a matter of fact, if you look at it, the teams would typically continue. If we had a 4th of July holiday, they would continue their velocity at that pace. So the team was really dedicated, and they wanted to make sure that they stayed on track. That was what they would try to do. And so it wasn't, if we had, let's say, we had a 3-day hackathon at one point, which really impacted a sprint, because it was 60% of the sprint. I think we rolled those 2 days into the next sprint or something to that effect. So the holidays didn't have a whole lot of impact on the data here. The dips you're seeing are typically after releases.
The one before that.
Oh, sorry. Oh, this one the dials on the focus factor or the velocity chart, I'm sorry.
I thought the blue one was the velocity.
Let's see now. Stability, focus factor, this one here?
Yeah.
Oh. Yep, so this was the percent of feature work that we did out of 100% of a given sprint.
Okay.
And the dips are where we maybe were doing bug sprints,
Okay.
or maybe some big infrastructure pushes.
Fantastic. 2 questions, if you'll allow it. Let's try. Sure. First, how come infrastructure bug fix isn't part of the backlog, right? So it's not part of the focus. And then, if you'll allow it, second question, what startup kit would you recommend to folks who want to gather metrics such as this to extend your work and give you more data points in more companies? So a similar level of rigor, so you can actually make it part of the same body of work in comparison.
2 good questions. On the first one, it was a common backlog, and we did pull from a common backlog. But we differentiated the blocks of work that were feature work from infrastructure and defect work so we could measure it, because we realized that it was a dial. So, because what we were promising the market was we wanted to forecast our features to see when our features might be complete. So I have some additional data that I'm happy to share, where we did our individual forecasts on those features, and we looked at how the feature grew over time, so that we can contribute to that forecast. But we also wanted to know how much were we spending on infrastructure. We wanted to know. It wasn't a separate backlog. It was the same backlog. It just was a tag, effectively, on a feature, that this was an infrastructure feature. Sure. The second question, I run a little workshop where I actually run through, starting with team velocities, where you go. And most of these data come almost purely from team velocity. You can do a lot of dashboarding starting there. But to get started, I may have to take that one offline and give you some really good some references there. But what I would argue is that make sure you know what you're measuring and why you're measuring it. It's probably the most important thing. So if you don't know why you're measuring something, it doesn't have any value. It's probably going to go sideways on you. So if you have a problem, find a way to measure that.
Was the unevenness in velocity viewed as an issue that there was sort of this burnout and then climb back and climb too high and burn out structure? Did you try to get a sustainable pace?
We did, and actually it was something that I pushed on. It was one of the metrics that we looked at every week at our sprint demos. So we did an operational review every week as well, okay, with a dashboard that had all kinds of data on it. And one of the things was the variability, or we measured it as a standard deviation. There were a bunch of engineers that figured they could handle a standard deviation. So we looked at that variability over time, because we knew that variability meant that there was a problem, that either there was churn in the backlog, people didn't understand the work that they were starting, or there were some other impediments in the way. So we used that as an indicator of flow. And if we had high variability, we would try to tamp that down. Now, we never wanted to get it down to 0. We dialed it in at about 15% was what we were looking at. We figured we want teams to blow up about 1 in every 6 sprints, because we want them pushing the envelope. This was a team that was really starting to do some innovative stuff. So the idea that we were going to wait until we had all the answers was not going to go. So we actually wanted to have a little bit of variability in there to drive that innovation budget, if you will.
Okay.
All right, thank you.